So next half an hour, then we'll just be talking about sky notes, a bit about what's happened in the sky and a bit about what's coming up. And I always like to start with a nice pretty photo, and this is a really nice one from Dennis Brzezinski up in Scotland on the Moray with the Aurora, which Jonathan showed the southern equivalent of it. This is the northern version, the Aurora Borealis. And either again a satellite glint or a meteor. One of the things these days you can never tell in still photos, when you get something that looks like it could be a meteor, it's almost just as likely to be a flaring satellite. So it's really video is the way to determine the difference between those two. But the Aurora, why isn't that working? The Aurora is reasonably active because the sun is becoming more active, which is nice to see. It's nice to actually be able to turn a telescope on the sun now and actually have a reasonable chance of seeing a few sunspots. This is the image from Solar Dynamics Observatory yesterday, showing a couple of smallish groups, but that's in comparison to the way the sun was a year or so ago, when we really weren't seeing very much at all. So the sun is beginning to wake up after a really long and low slumber. And we did wonder whether it was ever going to become active again. And some nice pictures here. This is from Simon Dawes. This is a white light image showing a couple of small active areas, but also some really nice detail, some facular detail, so these bright features here on the limb, and also the solar granularity. So it's possible to get some really nice images now. This is with an 80mm refractor. Possible to get some really nice images in white light. But of course, if you really want to get really interesting stuff on the sun, then hydrogen alpha is the way to do it. And this wonderful picture by Carl Barron showing these amazing features around a sunspot is just a really good example again of what amateurs can achieve in very high resolution imaging now, with very high speed, high frame rate webcams on the sun. Another thing that you can do is you can put things together in an animation, and this is from Luigi Moroni in Italy, showing a prominence, and this is over a few minutes just showing motion in a prominence put together as an animation. Most of the images that I'll show tonight are actually on our members pages, so if you want to go and have a look at them in a little bit more detail, go there. We've got a huge number of images now appearing on the members pages, really high quality, really excellent images. And definitely a great resource to go and have a look, and a great resource for me doing the sky notes, because I just need to go there and trawl out the best ones. Here's another really nice Aurora picture by Alan Tu up in Moray in Scotland. He always manages to get really photogenic shots, and here's a lovely Aurora in a nice dark starry sky with the reflection of the Aurora in the estuary there. So really nice views, and I'm really looking forward to being able to get up to the north of Scotland again and see stuff like this. One of the restrictions of COVID over the last 18 months or so is really not being able to travel around as much as we'd like. Of course, we're now coming into the noctilucent cloud season. They probably will be starting very soon. They're definitely worth looking out for. So as we get into the summer months, although it doesn't feel like summer at the moment, but as we get into the summer months, the summer twilight gets very long, even down in the south of England, and of course much more so in the north of Scotland. And the opportunity to see these amazing cloud features in the sky. So whenever you get the opportunity over the next couple of months, just keep a lookout to the north and see if you can actually see them. Normally you'll find the star Capella, which is low down in the north, and that's the kind of direction that the noctilucent clouds will appear. I know quite a lot of people now are just setting up automated cameras looking north to record these if they happen. So we tend to get quite a lot of images and movies. This is an example of some NLCs that we had last summer, actually on I think this was July the 10th, which was one of the days when Comet Neowise was at its best. So we had a comet and noctilucent clouds at the same time. So look out for NLCs if you get the chance. So the moon, of course, tends to drown out everything in the sky, and in fact it was very bright last night when we had some clear gaps in the almost permanent cloud cover that we seem to have at the moment. And in fact, if you look at the table there for new moon, full moon, the full moon was actually this morning at 11:14 UT. The next new moon is on June the 10th at 10:53 UT. A really nice picture here from the director of our lunar section, Bill Leatherbarrow, showing the crater Ptolemaeus, which is actually this crater here, but obviously shown here in much more detail. And again, examples of what you can do with electronic imaging of the moon now. So very high frame rates allow you to beat the seeing really and get remarkable resolution. So this lovely picture by Raffaello Lina from Italy, from Rome, showing Clavius, this big crater here. And it used to be that there was a kind of, if you could see some of these small craterlets on the floor of Clavius, that was a sign of really good seeing. Well, now they just are there all the time in really good images. But one thing I think that's important to say is that you don't need to have all of this really impressive electronic imaging gear to observe the moon. And I was really taken by this lovely drawing by Sally Russell of Gassendi, which shows a lot of detail in that crater as well. And this is with a 11-inch celestron at 290 times, and it's a really good representation of what you can see visually. And visual observing is still really important. Imagers get very fine images, but they can get artifacts in their images, and they can get things that aren't really there too. So having visual observers around to kind of keep things on the level is really good. And this excellent drawing by Sally. So hopefully that will encourage more people to actually go out and draw things. It's not something I've ever been very good at, but I did last month have a kind of sit down at the telescope and had a go at just visually looking at the moon and sketching down some stuff. Nothing that I would ever want to publish, but it was just very nice to do, and it gives you a really good impression of what's there to see through the telescope. So I mentioned that the moon was full or in fact full this morning, and if that corresponded to actually a total lunar eclipse. We couldn't see it from here, but it was visible over quite a large part of the United States and down in Australia. And a friend of mine, Jorg Schoppmeier, was actually in San Jose del Cabo in Baja, Mexico. He'd lugged along some equipment with him, and he sent me a really nice picture that he took this morning. So this was about lunchtime this morning, our time. So this is the total lunar eclipse that was visible from the west coast of the US and across the Pacific. We, though, do get an opportunity to see the eclipse that occurs 2 weeks later at the opposite node of the orbit. So this is a really interesting annular eclipse. And you'll notice from the diagram on the left here, which shows the red area in the shadow is actually where the eclipse is annular. So annular eclipse is where the moon's too small to cover the sun completely, so you see a ring. It's actually annular at the North Pole. So this is something that's very unusual. If you could get to the North Pole, then you would actually, assuming the weather cooperated, you'd see an annular eclipse. But given that we can't get anywhere, let alone the North Pole, I did look at trying to get somewhere to go and see this eclipse. And I even looked at going to Reykjavik in Iceland. And that is sort of possible at the moment because Iceland's on our green list, but they don't like us going to Iceland very much. You could go there, but it involves lots of quarantines and things. So I think most of us will see this eclipse from somewhere in the British Isles. And these are the timings. So this is June the 10th, the morning of June the 10th. From London, it starts about 9:08 UT, so that's 10:08 BST. a little bit earlier in Cardiff and Belfast, about the same time in Edinburgh. The magnitude from London is 0.3, so that's a reasonable sized partial eclipse. It gets bigger the further north and west you go. So the biggest from Great Britain is actually Cape Wrath, if you can get up to the northwest coast of Scotland. The biggest from the UK is over in Northern Ireland, so further northwest you can go. And if you could get to Reykjavik, it's 0.693, but it should be a nice partial eclipse for us. Very few people are actually going to get to see the annular eclipse because of the travel restrictions at the moment, but let's hope that we get clear weather on the morning of June the 10th for that eclipse. This is what it will look like. This is actually for London, so that's about 30-something% magnitude. So a reasonable partial eclipse. What's the probability of it being clear? I don't know. It'll be clear somewhere over these islands, so somebody will get some pictures of it. But whether we'll have a nice clear sky all the way through, I don't know. But it's a partial eclipse of the sun, June the 10th. So now if we move from the daytime sky to early evening, this is twilight now, actually on today, and there are 3 planets in the twilight at the moment. Venus very, very low, Mercury pretty low as well, and Mars, which seems to have been in the night sky forever, is in Gemini, getting lower and lower into the west. So all of those planets are really hard to image at the moment because they're all really small. So this is an image of Venus by Ron Palgrave, taken on the 10th of May. Not really showing a great deal, but it's just being able to get an image of the disk of Venus at all because it's so low down is quite an impressive achievement. Venus is moving out now, so we'll see it moving out in the twilight. It reaches its greatest elongation east on October the 29th. So through the summer, we'll see it gradually moving out into darker and darker skies. Mercury has been visible in the evening for the last few weeks. This is a picture from Graham Coates taken on May the 6th at about 9 p.m. UT in the evening, just as it's getting dark. So Mercury is actually now heading back in towards the sun, but there is a conjunction between Mercury and Venus coming up, which is mentioned on the BAA webpage, that's worth having a look out for, but you will need a very, very clear northwestern horizon to see that. Here's an image again by Luigi Moroni of Mercury. Pretty amazing resolution here. This, at the time this image was taken, the diameter of the planet, the apparent diameter, was 6.7 arc seconds. And what Luigi's done here is taken his image and compared it with a WinCom simulation, and you can see various bright features which line up, particularly Kuiper, which is this big impact basin on Mercury, which line up with features in his image. So that's pretty impressive stuff. That's with a 14-inch edge HD, so a nice telescope, but again showing what you can achieve with high frame rate imaging when the seeing's not so good. Mars is small as well. As I say, it's been around for a long time. It's heading in for conjunction, but because of the way that Mars's orbit works with ours, it takes an awfully long time to get there, so it doesn't actually reach conjunction until October. But this is an image taken by Damien using a 1-meter telescope, so pretty much as good as you can get, but amazing resolution. The diameter of the planet, the apparent diameter of the planet at the time this image was taken, was just under 5 arc seconds. And you see the amount of detail that there is on that planet. So just shows big telescope, very impressive image processing skills, and you can get a result like this. But Mars is pretty much disappearing now. Paul Abel has been continuing to keep it under observation as it drops in size and moves further and further away. This is from April the 28th, and it'll still be worth keeping under observation for as long as we can, but it just becomes more and more challenging as the planet gets further away and deeper into the twilight. Of course, one of the most exciting things that's happened on Mars over the last month or so is the flight of this little thing. This is the Ingenuity helicopter that was taken to Mars on the Perseverance rover. And it just is phenomenal, I think. When you think, you know, man can do some pretty stupid things, but what we've managed to do in terms of sending a spacecraft to Mars, a rover on its surface, and taking a little drone like this and flying it on Mars, where you're trying to fly something like this in a very thin atmosphere. Admittedly, the gravitational pull of Mars is rather less than on the Earth, but quite an amazing achievement, I think, to actually have a helicopter flying in the atmosphere of Mars. So when you do look at Mars and it's that tiny little dot in the field of view of your telescope, just remember that there's rovers moving around on the surface, spacecraft in orbit around it, and a little helicopter now sitting on the surface there too. So as we move into the darker part of the night, although it never gets truly dark from our latitudes in June. This is the view looking south at about 11 p.m. And we have familiar constellations there. So we've got the kind of spring constellations of Virgo moving over into the west. So still lots of galaxies to see if you want to have a look around Virgo and Coma Berenice. We have Boötes with Arcturus, pretty much due south. Corona Borealis, Hercules with the big globular cluster M13. And coming up in the east, we have the summer constellations of Vega, Cygnus, Delphinus, Aquila, all coming up with the Milky Way, the summer Milky Way rising up for us to see. So there are a couple of things I'll talk about in a second here, but we have, I'm going to talk a little bit about the minor planet Vesta, which is in the constellation of Leo, and a little bit about famous variable star R Corona Borealis, which is in Corona Borealis. So this is the light curve of our Corona Borealis, which is a pretty amazing light curve, really. It's a star that sits normally at about 6th magnitude, or at least it was normally about 6th magnitude, but it can get surrounded in dusty material, which makes it fall in magnitude down to a level where it's difficult to image even in kind of a moderate telescope. And this is the light curve over the last 13, 14 years. You can see that our Corona Borealis has come back up to about 6th magnitude. There was a little dip back in 2019, but it's currently about 6th magnitude. So it's an ideal object to keep under observation in binoculars and record your magnitude estimates and put them into the BAA variable star section database, because you never know when there might be another sudden drop in magnitude of this star. And it's ideally positioned at the moment for us. This is a lovely piece of spectroscopy done by Robin Ledbetter. This is of the asteroid Vesta, and it's just an amazing, exquisitely accurate piece of spectroscopy, where what we're seeing here is the same spectral lines from light reflected from Vesta compared to light in the sky. And the reason for the difference in the positions of these spectral lines is because of the Doppler shift. So it's because of the relative velocity of Vesta with respect to the sun and us. And Robin's done this. He's calculated that the Doppler shift he measures is 14.5 kilometers per second. And if you actually go to an ephemeris for Vesta on JPL, it's actually about 14.2. So he's within 300 meters per second of calculating the relative velocity of Vesta with respect to us and the sun by doing spectroscopy of it. And I just think that's an amazing thing now, that amateurs are able to do spectroscopy with this level of precision, that they can determine these velocities. If you turn around and look north, we have a lot of familiar constellations. The Plough Ursa Major is heading down in the northwest. We have Hercules and Cygnus coming up in the northeast. But we have quite a lot of interesting objects. So there's a few galaxies in Ursa Majors. So we've got M81 and M82 and M51. So some really nice photogenic galaxies to look at in Ursa Major. But we've also got a large number of novae. We've got 2 novae that are in the constellation of Cassiopeia and 1 that's down in the constellation of Perseus. So those novae are visible throughout the night. The Cassiopeia ones are, because they're circumpolar. They get better in the morning sky, but they're interesting objects to observe if you get a chance. So in terms of the galaxies, this is a lovely image of M51 taken by Martina McGovern back in February, actually, but it's still an object that's available now. There have been lots of pictures of M51 appearing on the members pages. It really is an impressive and spectacular galaxy, and worth having a go at if you have the appropriate tools to take images. But just looking visually, it's impressive to look, and thinking about the Earl of Ross and Burr Castle when he first determined the spiral structure of galaxies by looking at this thing through his massive 72-inch telescope in the middle of Ireland. And you know, we might complain about the weather, but I don't think I've ever got any wetter than when I was at Burr Castle in Ireland. The rain there is just on a different level to what we get here. Variable stars. The variable star section has got a few programs going. Jeremy asked me to mention this one. This is for a star called CG Draconis, so up in Draco, nicely placed at this time of year. Have a go at observing that one. Have a look on the BAA website for more information about the variable star section observing campaigns. I mentioned the novae, and this one is the nova that's really been in the news. This is Nova CAS 2021, V1405 CAS. It's in a very busy part of the Milky Way, but it's become easily bright enough to be visible in binoculars, even from quite light polluted places. And it's in a really interesting and nice part of the sky. This lovely picture by Mazen Younis shows it in the Milky Way. So here's the nova itself. You've got the lovely open cluster M52 up here, and NGC 7635, which is the bubble nebula, just about a degree to the right of it. So it's a relatively easy object to find. If you haven't seen it already, go out and see it soon, because it may well start fading soon. But it's just been through a really interesting brightening phase. So almost from the point it was discovered, it was at about a magnitude somewhere between 7.5 and 8. And it sat there for a month, more than a month. And then just at the beginning of May, it suddenly brightened from about 7.5 to 5.5. And then almost as suddenly has faded back again to where it was before, about 7.5. So during this period, it became one of the brightest novae that we've had for quite a long time, and very well positioned for us to see. So definitely an object that you can do visually with binoculars. As I say, a relatively easy thing to find. I managed to find it with a pair of binoculars sitting in a chair in the garden, and if I can do it, then you can, because I just rely on GoTo most of the time for everything. Again, Mazen took some pictures showing what happened during this anomalous brightening, or this brightening period. It went from being a star that was relatively neutral color to very, very strongly reddened. And the reason for that reddening is shown nicely in this spectrum by Mike Harlow. So this is a spectrum taken with a relatively old-fashioned way of doing spectra. It's a thing called an objective prism. And you can see these bright lines here. These correspond to hydrogen emissions. So this is hydrogen alpha. And the nova has a very strong emission at hydrogen alpha, which is red, which is what made it this red color. Another lovely spectrum here. This is Hugh Allen. This is how this spectrum evolved over a period of a few weeks through April and May. And it shows quite nicely a thing called the P Cygni profile, which is where you have light both in absorption and emission from the same gas, but moving at different velocities in our line of sight. So another really nice example of spectra on novae. A couple of other novae, one that's been around for a while that faded quite a long way, V1391 Cass. It went all the way down to about 21st magnitude, and it struggled back up to about 17th, 16th magnitude. It's quite a difficult one to make estimates of because the nova is only about 5 arc seconds away from a 16th magnitude or a 17th magnitude star. So when it faded a lot, people were having trouble separating the two. And then finally, this one, this is the Perseus nova, V1112 Persei, which is kind of, was about 9th magnitude, faded down to about 16, and it's now come up to about 14, 14 and a half. So all three of those novae are definitely worth keeping an eye on. And if you're doing photometry, another thing that's worth doing, and Roger Dimmock asked me to mention this, is to go along to the BAA website and have a look on the ARPS exoplanet web pages, because there's a new project looking for microlensing, planetary signatures in microlensing. So where you get a star moving in front of another star, causing this microlensing event, if you happen to have a planet in orbit around that star, you can get a little glitch on the curve here. And so there's lots of work to be done. This is a really exciting area to be working in. Have a look on our website and join one of those projects. Coming around to the morning sky now, as it's getting light, there are two planets in the morning sky, Jupiter and Saturn, low in the morning sky, very low for us. Okay for people in Australia. So this great image of Jupiter by Mark Lonsdale in Canberra, showing Jupiter, it's about 40 arc seconds across, heading to opposition on August the 20th, so coming up in a few months. And Saturn as well. This is another one. This is from David Pistrito in Italy, showing some really nice features in Saturn. But even actually from the UK, here's an image by Peter Tickner, which I think is pretty extraordinary given how low Saturn is at the moment. So both of those planets are available in the morning sky. So if you get up around 2:30, 3 a.m. BST, you can see those. So I'll just finish with some bits of debris in the solar system, some large bits and small bits. The large bits are the comets. We've had a reasonably nice comet. This is C2020 R4 Atlas. This is an image. I haven't noted whose image it is. I'm sorry about that, whoever's image it is. I'll find out later. But anyway, so this is C2020 R4. And it got to about 10th magnitude, maybe a little bit brighter than that, and was quite a nice comet through April. And it's another comet that's been the subject of spectroscopy. And here's some work done by Robin Ledbetter looking at the comet. It was bright enough that you could actually get some quite interesting spectra, looking at different parts of the comet and looking at the components of the comet, whether it's the dust or the gas in the coma or the gas in the tail. So again, another example of spectroscopy being used on relatively faint and difficult objects. 2020 R4 has faded now, and it's been overtaken by this comet. This is currently the brightest comet we have in the sky. This is 2020 T2 Palomar. Again, it's reasonably well placed for us. A nice image here Martin Mobley took of it passing by the globular cluster M3 a week or so ago. So this is probably, well, it is the brightest comet in our sky at the moment, worth going out for. At the other end of the scale, this tiny little faint smudge here in Peter Carson's image is a very famous comet. This is the comet 67P Churyumov-Gerasimenko, the comet that Rosetta went to. And the comet is coming back now to perihelion later in this year, in November. And it's going to be a really good return for us. It could get reasonably bright. It could get to, say, 8th or 9th magnitude, potentially for us in November in the morning sky. And a really interesting comet to keep observing. It's a comet that we probably know more about than any other comet in the solar system because Rosetta went there. So sitting on the surface of that faint smudge is Philae, the little lander that Rosetta sent to land on the comet. But the big spacecraft Rosetta is on the surface as well because it was put there in a controlled impact to ensure that it didn't fly off into space and interfere with other things. And this actually is the last ever picture that Rosetta sent back of the comet, taken by its wide-angle camera when it was only about 25 meters above the surface of the comet in September 2017. The reason it looks out of focus is because the camera was never intended to focus that close, but it's probably resolving things down to a few millimeters. So whenever we observe 67P, it's just kind of, again, a bit like observing Mars. Just realize that there are things on the surface that we put there. Pretty amazing. And then finally, meteors. The summer is a pretty quiet time for meteors, but this is one of the showers that we've just had. This is the Eta Aquarids. The Eta Aquarids are meteors that come from Comet Halley. And in fact, Comet Halley causes two meteor showers in the year. One of them is the Eta Aquarids. The other one is the Orionids that take place later in the winter. They happen at different nodes along the orbit. But the thing about the Eta Aquarids that's interesting is that the radiant rises only just before dawn. So the meteors that we see are generally very, very long. So that one was Alex Pratt, and this is a video that I got of another Eta Aquarid back in the middle of May. So what we're seeing here is meteors that are almost at grazing incidence to us. So a nice shower, and I think the rates for the Eta Aquarids this time around were relatively high. So not much over the summer really until we get to the Perseids in August, but at least this year the moon is cooperating, and so we should get a really good, if we have good weather, we should get a really good Perseid display this year, because the skies will be dark right up to maximum. And then final slide is this. This is the Winchcom Meteorite. You may remember that we had a webinar on the BAA webinar series back in January, where we had essentially Jim Rowe was talking about how the UK Fall Network had set up some cameras with the intention to detect fireballs and actually determine meteorite falls. Little did we know that less than a month after that there would be a big fireball and that there would be a big collection of meteorites that came from it. So the video on the left there is the view that one of my cameras got from Chelmsford. Not a particularly good view because the fireball was coming directly at us. But we calculated the path, and the UK Fall guys predicted where these things would fall. And it was big news at the time that a lot of meteorites were picked up, carbonaceous chondrites, in around Winchcombe in Gloucestershire. So one of those is now gone on display in the Natural History Museum in London. And now that the COVID restrictions have been relaxed, museums are open again. So you have the opportunity to go along to London to see this pristine carbonaceous chondrite. I certainly will be going. I've booked a ticket. You have to book a time slot now because of the restrictions. But I'll be going to see this in London, because the last time I saw this was vicariously through my camera far to the west of me, burning up in the atmosphere. So really nice connection between something we see in the sky and something which is now on the ground. So have a good summer. Hopefully the weather will improve from what it has been. It's been pretty dire for the last month or so. But look out for noctilucent clouds, look out for, look at those variables, look at the novae, particularly watch out for the eclipse on June the 10th. And if you get a chance, go along to the Natural History Museum to see some astronomy actually on the ground. So thanks very much.
Thank you, Nick, for an excellent Sky Notes. And it was I think like you, I do like to do sketching once in a while, but I'm not sure I'd share my results.
No, mine hasn't improved since I was about 10.
Yeah, sounds about me. Well, the next webinar is on sketching deep sky objects, so I'm going to see if I can pick up any notes from Benish at that. And thanks again to Jonathan for giving an excellent George Alcock Memorial Lecture tonight.
Yeah, thanks, John.
Pleasure.
And thanks to everyone who joined us. We've had about 60 to 70 people with us tonight. And we usually get quite a few people watching on YouTube once the recording goes up. So, and hopefully in due course, we'll be able to actually meet face to face.
That would be good. I'm looking forward to that.
Great. Thanks all.
Cheers.
Bye.
Bye.
Bye.